Section 3.1, Graphing Linear Equations. Essential question. How do you determine if a graph is linear or nonlinear? So our two vocab words for this lesson are linear and nonlinear. If something is linear, you just look at part of the word linear and you'll see the word line. So the graph is a straight line. If a graph is nonlinear, it is not a straight line. So there's lots of different ways our graph could look if it was not a straight line, but it could make a V, it could be a parabola, it could be a wave. So lots of different possibilities for nonlinear. But you have to just look at the parts of the vocab word. Linear, meaning line. Nonlinear, meaning not a line. All right, graph the equation. Y equals 2x plus 1. We're going to be asked to answer two questions for each of these examples. Is it linear or nonlinear, and is it a function? Now, if we need to graph an equation, the easiest way to do that is by making a table. When we have an equation like 2x plus 1, we want to have a few negatives, 0, and a couple positives. So I'm going to make my table be -2, -1, 0, 1, and 2. So I've got 2 negatives, 0, and 2 positives. That should give me a good idea of what my graph will look like. So now I have to take -2 and plug it into my equation. So 2 times -2 plus 1 will equal, well, 2 times -2 is -4. -4 plus 1 is -3. All right, now if I plug -1 into my equation, keep in mind when I say plug it into my equation, I'm just plugging in for x. These are my x values, so I'm plugging it into x in my equation. So 2 times -1 plus 1. Well, 2 times -1 is -2. -2 plus 1 is -1. 0, 2 times 0 plus 1. Well, 2 times 0 is 0. 0 plus 1 is 1. 2 times 1 plus 1 would be 3. And 2 times 2 plus 1 would be 5. So now I have 5 ordered pairs. So -2 and -3 is an ordered pair on my graph. -1 and -1 is an ordered pair on my graph. 0 and 1. 1 and 3. 2 and 5. So now I'm going to take all these coordinate points and graph them. Remember, when we graph, we always go left and right, then up and down. So if I start with -2, -3, be right here. -1, -1, 0, 1, 1, 3, and 2, 5. So if I connect my dots, you'll notice I have a straight line. So since I have a straight line, my graph is linear. Now, is it a function? Since I have a graph, I can do the vertical line test to determine if my graph is a function. So if I draw vertical lines through my graph, my line should only touch my graph one time each time. So it touches once right here, once, once, once. Yes, it is a function. It passes the VLT. Vertical line test. next one. So again, we're going to start with our table, and we're going to put our 5 values down. -2, -1, 0, 1, and 2. I'm going to take all of these x values and plug it into x in my equation. So -2 squared plus 3. Well, remember, -2 squared, a negative number squared, is that number times itself. So -2 times -2 is +4. 4 plus 3 makes 7. If you're putting that into a calculator, you have to put the -2 in parentheses, otherwise it won't end up with the correct answer. -1 squared plus 3. -1 squared is 1. 1 plus 3 is 4. 0 squared plus 3. 0 squared is 0. 0 plus 3 is 3. 1 squared plus 3. 1 plus 3 is 4. And 2 squared plus 3. 4 plus 3 is 7. So this time our 5 ordered pairs are -2, 7. -1, 4. 0, 3. 1, 4. And 2, 7. All right, let's start graphing them. So -2, 7. -1, 4. 0, 3. 1, 4. And 2, 7. So if we connect these points, they are not going to make a straight line this time. This is called a parabola. Anything with an exponent will make a parabola. So a parabola is nonlinear. And let's do our vertical line test. So make straight lines through our graph. It passes, 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 passes. So yes, it is a function. It passes the VLT. All right, this time we've got absolute value. So the absolute value of x minus 3. So our table of values, -2, -1, 0, 1, and 2. So the absolute value of -2 minus 3. Well, the absolute value of -2 is 2. 2 minus 3 is -1. Absolute value of -1 minus 3. Absolute value of -1 is 1. 1 minus 3 is -2. Absolute value of 0 minus 3 would be -3. Absolute value of 1 minus 3 would be -2. And the absolute value of 2 minus 3 would be -1. So this time our 5 ordered pairs are -2, -1, -1, -2, 0, -3, 1, -2, and 2, -1. So if I graph those 5 ordered pairs, absolute value, when graphed, always makes a V. So a V would be nonlinear. And if I perform the vertical line test, it touches once, 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 once. Yep, it's a function. It passes the VLT. Summary.